So welcome to module 3. So we're going to continue what we did from frequency distribution. So what we did in frequency distribution was that we had a set of data and we made it look like as though something that we can do with it by using frequency distribution. And then we can infer certain things from there. There are a lot of other ways of inference in statistics. One of the most common ways of inference is basically what is called measures of central tendency. Okay, so we're going to say how data sets can be looked at in a different perspective altogether. Okay, so we have various data, and I'm going to look at various data in a different way. So first thing I can do is, so I have data 1, 2, 3, 4, 5, all the way till 10, right? I can actually make this 1, 2, 3, 4, all the way 10 into a graph. So I'm going to make a graph, and I'm going to, what is this? What is the midpoint of this? The midpoint, let's say, is 5. Okay, and I'm going to go from 0 to 5, 0 to 5, and then 5 to 10. And I'm going to say this is my midpoint, and this midpoint is my what is called an average or mean. So now I have taken this 1 to 10 and I've drawn it in such a way that this is 0 and this is 10, this is 1, this is 2, this is 3, this is 9, this is 8, and this is going to be 5. Something like that. So I can pretty much take this data and move it into what is called a central tendency. The reason why I'm doing this is going to be this way. Now, if you look at it 0 to 10, I can say that 5 is in the middle. Okay, 5 is in the middle. How far 0 is from 5? How far 10 is from 5? How far 1 is from 5, and how far 9 is from 5. I can do all those kind of things. And this gives me what is called the variance. Basically what I'm saying is that my midpoint is 5, and now this point 1 is going to be away by -4. This point 9 is going to be away by +4. You can see that, right? So +4 plus 5 is 9. 5 minus 4 is 1. I can do that, right? So basically I'm seeing that this point -4 is away from this whole middle, and this point 9 is away from this whole 5. How much is it away? It is away by -4 and +4, and that is my variance. Okay, so when people talk about variance, how the data point has drifted from the mean, has moved away from the mean, is what we are talking about as variance. And this is also called measure of dispersion. Okay, so a simple data 1 to 10 can be made into various ways in statistics and looked at in various methods in statistics. So in summary, what we are doing here is we're just taking this data 1 to 10, and then we are drawing this 1 to 10 like a frequency. These are the frequencies 1, 2, 3, 5, 8, 9, and 10. And we are seeing that the central point is 5. And then from the central point, what is away? This is negative, and this is positive. So 9 is 4 positive to 5, and 1 is 4 negative to 5, right? And that is the variance we are talking about. So we can actually look at it from different angles, the same data that we have. Let's explore further. Okay, so the first thing we want to talk about is what is called mean. Mean is same as the average. Okay, what is an average? Average is if I have data 1, 2, 3 is the data. So I have 3 data. 1, 2, 3. 3 data. Okay, and the addition of these is 3 plus 2 is 5 plus 1 is 6, and the mean is going to be 2. That is the basically how I'm doing it is I'm adding all the data and dividing it by the number of data that I have. That is my mean. Okay, an example is this. If I have values 5, 8, and 2, what are the number of values? I have 1, 2, 3 numbers. So that's why I have number of data values is 3. The addition of data values is 5 plus 8 plus 2, which is 15. So 15 divided by this 3 is going to be 5, and that is my mean. Okay, so this is a simple mean that I can calculate very easily. And let's go to the next one, which is the population mean. There are 2 types that people do in statistics. One we call a population, another we call a sample. Okay, we will see what is population, what is sample in a few minutes. You remember when we talked in the module 1, go back to module 1, and then when we talked about the sample and the population, you remember I said I want to find out the attention span of my dog. So to do that, if I really want to know the attention span of dogs, okay, then I have to look at every dog in the world and make observations. I don't have that luxury to do that. So I'm going to use my dog and then say the observation of my dog's attention span. So that basically is the sample that we are talking about. The population is all the dogs in the world. So by the sample, I can say, the attention span of dogs is going to be, so much. I can generalize it using that sample. And that is what we talked about in module 1. So go back to module 1, understand what is population and what is sample. And now, going back to our way of looking into sample and mean, we're going to look at mean from a population point of view as well as a sample point of view. Okay, so how do we do that? The population mean is basically the denotion. First make sure that how we denote this. When we say mu, this is pronounced as mu, that is population mean. When we say x bar, that is actually sample. So if I take the whole population and find the mean of that, that is the population mean. If I take a sample from the population and then find the mean of that, that is going to be by sample mean. Okay? So when I say sample mean, basically I denote using this formula. Now, don't get scared about this formula. It's actually very simple. So let me try to explain this formula first, and then we can go from there. This formula basically has got one symbol, which is called the sigma. Sigma is a Greek letter for addition. That's all it means. Okay. So when I say sigma of x, that basically means any value of x I'm going to add. So if I have 1, 2, 3 as x is equal to 1, x is equal to 2, x is equal to 3, sigma of x is going to be equal to 1 plus 2 plus 3, which is 6. That is what is sigma of x. Okay. Now, I also have what is called I is equal to 1 to n. And then I put x of I. Basically, what it happens is here, instead of saying x1 plus x2 plus x3, I put xi 1 to n, where n is the number of data. So I have n is equal to 3 here. Okay, n is equal to 3, 1, 2, 3. So instead of saying x1 plus x2 plus x3, which is 1 plus 2 plus 3, I can say x of I, where I is equal to 1 plus n. So I can actually go on forever. If I have 15, it'll be x1 plus x2 plus x3 plus x4 all the way till x15. And that's what this whole thing is all about. Okay, so when I say this portion of it, xi of sigma I is equal to 1 to n of xi, basically means how many i's are till n. And n is actually the number, the total number. Okay, so basically you can do this. Let's say the traveling time to class from your home is clocked every day. So you clock it, say Monday 9th through Friday 9th, 13th in minutes. And you come out with these, this is how long you take from your home to the class every day, from Monday to Friday. You make some observation. Now I want to know the sample mean. This is a sample mean because you are actually attending lots and lots of classes. All we are doing is basically just a few of those classes. That's why it is a sample out of a big population, right? And the sample is going to be 30, 35, 32, 34, 36. It takes you 30 minutes on the first day, 35 minutes on the second day, 36 minutes on the fifth day. Okay? Now we want to find the mean. What is the average time it takes for you to come from your home to the class? All I do in that case is going to apply this equation. I'm going to apply this equation. How do I apply this equation? I'm going to find the sigma of xi, which is going to be equal to 30 plus 35 plus 32 plus 34 plus 36. I'm adding all these numbers, and that comes to 167. That is going to be my sigma. 167 is my sigma of xi. N is going to be equal to 1, 2, 3, 4, 5 days. So I'm going to have 5. So 167 over 5 is 33.4. That is my average time it takes for me to come from home to class. And that is my sample mean. And that is my sample mean. Because I come to class so many times, but I'm taking a sample of 5 days. And I'm using the mean of those samples. That is why it is a sample mean. Okay? Let's do one more thing. So here we're going to talk about weighted mean. Here I'm going to add one small complexity. What I'm going to do is this. I have a project. I have a midterm exam. I have a final exam. Okay? And I get 94 in my project, 89 in my midterm, and 83 in my final. But I've also put weights on it. So the instructor has put a weight of 50% for the project, 35% for the midterm, and 15% for the final. Okay? So when I place these weights, how do I find the mean? By average. So first of all, what we need to do is to multiply the score and the weight. And then use that as my number for the sigma. That's what I'm doing here. Here I am doing the weight times the numbers that I have, the scores that I have, over how many times we had, how many scores we had, what is the total scores we had, total weights we had. So this is the total weight. The total weight is 100% because 50 plus 35 plus 15 is 100%. Okay? The sum of the weights is actually 100%, which is actually 1, right? 100% is 1. So we know that. So we have done this in basic math. You remember? The same thing we are doing here. Now the weighted score is going to be 94 times 50%, which is 47. 89 times 35%, which is 31.15. 83 times 15, which is going to be 12.45. So the total is 90.60. Okay, the total of the 90.60. 90.60 divided by 1 is going to be 90.6. So here I'm doing